Welcome back. Today we're going to look at the unit circle. And the definition of a unit circle is it's a regular circle, just like you're used to seeing, and the radius is 1 unit. So when we write the equation of the circle, it'd be x squared plus y squared equals r squared, but since r is 1, it'll just equal 1. So there's two ways that we can represent any point on the circle. We can actually use the angle or the arc length, and then we can also use a point, just like we're used to using coordinates x and y. All right, so what we're going to do is look at the unit circle, and we're going to use the special triangles that we've discussed before. So here we're going to have a 45 degree, or I could say 45, 45, 90. And I don't even need to write up there because we're really concerned with this angle. So if you know 45, well, 45 is going to be half of 90. So here we have the 90, we have the quadrantals. So what I can do is, since this is a unit circle, I'll first label any points that are on the x and y axis. So we know that this coordinate would be just 1, 0. This coordinate would be 0, 1. This would be -1, 0. And down here would be 0, -1. Now I'm going to write the angles in here. So we know that this angle would be 0 degrees. And I'll include both because it does have two spaces. So we'll have 0 and 360. And then over here we'll just put 0 radians or 2 pi, right? Because that'll be a full circle. And then when we hit 90, well, that's pi over 2. And then over here we'll have 180, which is just pi radians. The colors are starting to blend together here, so write that a little bit more clearly. And then over here we have 270. And in radians, that would be 3 pi over 2. All right, so as we go around the circle, we have 0, pi over 2, 2 pi over 2, which simplifies to pi, 3 pi over 2, and then 4 pi over 2, which reduces to 2 pi. All right, now I'm going to look at the 45, 45, 90. So, right, we have a 90 right here, so we know that half of that would be 45. So we can also write that as pi over 4. So pi over 4, and then we get to 90, that would be 2 pi over 4, which reduces to pi over 2. And then we'll get 3 pi over 4 over here, which will be 135. All right, and then we're going to add 45 again to get to 180. And then we can go down here to 225. And we know that this would be 5 pi over 4. So we're continuing that, adding pi over 4 each time for 45 degrees. And then we add pi over 4, we get 6 pi over 4, which reduces to 3 pi over 2. And then we're going over here to 315 in the fourth quadrant. And this would be 7 pi over 4. And then when we get back to 0, well, that's going to be 8 pi over 4, which is 2 pi. Okay, so what we want to do is look at the right triangle, 45, 45, and we know a couple things, right? We know that if this radius is 1, then we know that this height, or this side, would be root 2 over 2, and this side would be root 2 over 2. So if I draw this triangle here, and I'm just going to draw it with a different color, you can see pretty clearly that the x value of the coordinate would match the adjacent side to that angle, and the y value of the coordinate would equal the opposite side. So when we write this as a coordinate, well, this would be root 2 over 2. Root 2 over 2. So we're in the first quadrant here. And then when we get over to the second quadrant, well, we know it's going to be the same values except x will be negative. So it's negative root 2 over 2. The y value is positive root 2 over 2. And then we go over to the third quadrant where both the x and the y are negative. So that's negative root 2 over 2, negative root 2 over 2. And then we'll go to the fourth quadrant where only the y value is negative. So this is root 2 over 2 and negative root 2 over 2. So we can see this 45, 45, 90 triangle repeat itself all throughout the unit circle. All right, let's go to another one. So now we're going to look at pi over 3. So again, just going to label some of these points here. So this was 0 to pi, and I could put 0, I'll use a different color for degrees. And then we have this is pi over here, pi over 2, 3 pi over 2. And what we're going to do is look at, I'll put the degrees here in a different color, like I said. So this is 0, 360, 180. All right, so the key parts is we're looking at the 60 degrees. Okay, so when I have the 60 degrees, well, it's going to be up here. All right, so the 60 degrees, I'll mark with here, and we know that if we add another 60, that would be 120, and then add another 60, that's going to bring us down to 180. And then I go over here, add 60, we have 240. Add another 60, we get 300. Add another 60, we get back to 360. All right, so let's put these in radians. So we know that the first one, pi over 6, would be, sorry, that would be pi over 3 would be 60. And then we have 2 pi over 3. 3 pi over 3 reduces to 180. Then we have 4 pi over 3. 5 pi over 3. And then 6 pi over 3 takes us back to 2 pi. Okay, so for this one, we're looking again, like I said, at this on the 60, the 30, 60, 90, but focusing on the 60 degree here. And this is not drawn to scale because we know this is 30. Let me just draw this a little bit better so we can have it a little bit more to scale. So it's a little bit steeper. Just a little bit there. And then we know that's 30 up there. So we're really looking at the central angle. All right, so we know that this side over here would be 1. And that if it's going to be half of the radius. So if this has a unit, it's a unit circle, so this is a radius of 1 or a hypotenuse of 1, then this would be 1 over 2. And then we know that this side would be root 3 over 2. So when we draw this on the unit circle, and I'm just going to draw this here so you can see. So you can see right here is the 30, 60, 90. And again, here's the 60 degree. We can see that that x value, that coordinate, would match the 1/2. And we know that the y value would match the opposite side. So we know that this coordinate would be 1/2 for x and root 3 over 2 for y. Now we're going to use those same sides, those same lengths, and just change them from positive to negative as we go through the quadrants. So this will be negative 1/2 in the second quadrant, but the y is still positive. In the third quadrant, both the x and the y are negative. So negative 1/2, negative root 3 over 2. And in the fourth quadrant, just the y value will be negative. So 1/2, negative root 3 over 2. All right, for our last special triangle, we're going to look at the 30 degree. And it's going to have a little bit of repetition with the 60. So when we have the 30 degree, I'm going to draw this triangle here. So we know that this is going to be 1, 1/2, because that's the opposite side of 30, and then this will be root 3 over 2. And you can start to see when we draw this triangle here, here's the 30, that the x value matches the adjacent side and the y coordinate matches the 1/2. So what we're going to do right here, I'm just going to use the 30s on, we already have some of the 60s in there. So this is going to have a coordinate, and it's 30 degrees, or pi over 6. That's going to be √3/2 for the x coordinate, and then for the y, 1/2. And you can kind of tell the x coordinate is longer, right? That side is going to be longer. The y is going to be shorter. All right, so I'm going to skip over here to find the other triangle with a reference angle of 30, right? But this isn't going to be 30 degrees, right? Here's this, it's a semicircle, right? So this right here is 180. Let me just use a different color so you can see. And then over here, this is going to be 150. And that's fine because we already figured out from above 120 and 60, 90, all those other multiples of 30. So now we're just looking at the special triangle of 30, or pi over 6. And so we know that this is going to be 5 pi over 6 because we subtract pi over 6 from pi. So the only value that becomes negative in the second quadrant would be the x. So this will be negative √3/2. And a positive 1/2 for the y. And let's go over here down to the third quadrant, where we're going to still use the reference angle of 30, but now this will have a measure of 210 because 180 plus 30 is 210, and then we could add pi over 6, so this would be 7 pi over 6. All right, so in the third quadrant, both the x and the y will become negative, so this is negative √3/2, negative 1/2. And finally, for the fourth quadrant, or again, if this has a reference angle of 30, the full rotation is 360, this would be 330. And then remember, we have 2 pi, or really 12 pi, so this will be 11 pi over 6. And again, in the fourth quadrant, only the y value becomes negative. So this will be √3/2, negative 1/2. So we put all those together. We put the special triangles together, and we included the quadrantals over here, the 0, 90, 180, and 270. And all together, you can have the unit circle. So you can see in this unit circle, you have all the coordinates. So here's the quadrantals, 1, 0, 0, 1, negative 1, 0, 0, negative 1, because it's a unit circle with radius 1. And then you can start to see all the special triangles. So you can see the 30, the 45, the 60, and you can notice that all of these are going to be very similar. Look at the 30, which we just finished. It's negative, the x is negative in the second quadrant. They're both negative in the third quadrant. And the y value is negative in the fourth quadrant. Now let's look at some of the properties of trigonometric functions. So when we look at the coordinate x, y on the unit circle, it actually indicates these trig functions. So we have been using it with the unit circle, but when we look at the y value, that has corresponded with the sine. So sine of any rotation here, or arc length, t, can be represented with y. So the y is going to be the sine. And then we have the cosine. Well, we saw that that adjacent side showed the length for x, or the coordinate for x. So cosine of t relates to x. Now when we look at tangent, well, tangent is going to be the opposite over the adjacent. And we could tell from the circle that we have, I'm just going to write this clearly here. So we have the y value and the x. So when we look at this angle right here, the tangent would be y over x. Now when we look at the reciprocal functions, well, we just have to find the reciprocal of each of these. So cosecant of t can be represented with 1 over y. The secant can be represented with 1 over x. And the cotangent can be represented with x over y. Now remember, we have these 6 functions, and it depends on the coordinates to see if they're going to be positive or negative. And so remember, in the first quadrant, both the x and y were positive. In the second, the x is negative. In the third, they're both negative. And then in the fourth, the y is going to be negative. So when we look at the x and y, you can see right here that all of them are going to be positive. All the y, the x, and the y over x, any of those quotients are going to be positive in the first quadrant. So all of these trig functions will be positive if the angle lies in the first quadrant. If the angle lies in the second quadrant, the ones that will be negative, anything that has an x will become negative, right? Because that's the negative coordinate. So we know that cosine will be negative and tangent will be negative. So the only one that will be left is sine and cosecant. So we put sine here in the second quadrant. Now when we look at the third quadrant, they're both going to be negative, the x and the y. So anything that has x or y will become negative. So sine will be negative, cosine will be negative. Only tangent and cotangent will be positive because both cotangent and tangent have negatives, or both the x and the y. So two negatives make it positive. So I'm going to put a T right there. Now for the last quadrant, for the fourth quadrant, anything that has a y is going to be negative. So the sine will be negative, the tangent will be negative, but the cosine and its reciprocal is going to be positive. So you may have heard this acronym already, and it's going to be true for everybody in this class because everybody's so bright. So we use the acronym All Students Take Calculus, and that helps us to remember which ones are going to stay positive. So in the first quadrant, all of them, so sine, cosine, tangent, and the reciprocals are going to be positive. In the second quadrant, only the sine and its reciprocal, don't forget they're kind of together here, the cosecant will be positive. In the third quadrant, only the tangent and its reciprocal cotangent will be positive. And then in the fourth quadrant, the C, where we say all students take calculus, that represents cosine and secant. And those two functions will be positive. So to remember we try to, when we name this quadrants, you try to make the letter C. So you start in the top right and go around, okay? Counterclockwise. So 1, 2, 3, 4 for those quadrants. All students take calculus. Okay, now let's go to evaluating these trig functions. So for each of these, we're going to first figure out which quadrant they lie in, what's the special triangle, and then hopefully we can figure out all these values together. So when we look at 5 pi over 6, I'll make a little sketch here. But we know that 5 pi over 6 is going to be a counterclockwise rotation, and it doesn't make 6 pi over 6, which is the pi, so it has to be in the second quadrant. That's going to be in quadrant 2. And we know that this angle right here, and I'm going to use green, this is going to be a reference angle. And we know that that's going to be pi over 6, or you say 30, right? So if that's going to be 30, then we could think, all right, well, if this is 30, then this is the shortest side over here, right? So that'd be 1/2. And then we have the x-coordinate is -3/2 for the unit circle. So you can also just leave the same ratios with 30, 60, 90, the negative, the root 3, 1/2, and 1. But I'm just going to leave them here because we want to figure out the sine cosine. So remember, the sine is the y, so that's going to be 1/2. It's in the second quadrant, so we know that the sine and the cosecant will be positive, so that's just going to be 2. The cosine is going to be negative, so that's negative root 3 over 2. And the reciprocal of that's 2 over root 3, so I'll write 2 root 3 over 3, and they're both negative. And then the tangent, that's going to be 1 over negative root 3. And so I'm going to write this as negative root 3 over 3. And then the cotangent is just negative root 3 over 1, so negative root 3. Now let's look at 7 pi over 4. 7 pi over 4 is going to almost take us to 8 pi over 4. Right? 8 pi over 4 would be a full rotation. So this one is going to take us to the 4th quadrant. And we know that this is a special triangle. This is going to be a reference angle of pi over 4 or 45 degrees. So we know that the ratio here, they're all going to be the same, right? So you could use 1, 1, root 2, or you could use the root 2 over 2. So this will be root 2 over 2, but it's negative because it's in the 4th quadrant. And then we have positive root 2 over 2. And then the reciprocals, well, we think about it's, if this was 1, let me just write it with a special triangle, root 2, right? So that would just be negative root 2 and positive root 2. And then the tangent, well, that's just going to be 1. So it's in the 4th quadrant, so we just got to make sure we put negative 1. And the reciprocal is cotangent. All right, let's look at negative 2 pi over 3. So negative 2 pi over 3 is going to take us into the 3rd quadrant. Make it a little steeper here. Okay, so this is going to be negative 2 pi over 3. And I'm making sure that I use a reference angle here that has one side on the x-axis. So this is negative x-axis. So this is going to be negative 2 pi over 3. So this reference angle is pi over 3, or 60. Right? I'll just put 60 here. You could still use the degrees as a reference as well. Okay, so if we know that's 60, well, we know that both the sine and the cosine are going to be negative because it's in quadrant 3. But we also know this, since it's a 60-degree angle, this will have a root 3 and a 2. So when we look at the sine, that's going to be negative root 3 over 2. Oh, I wrote these sides wrong, sorry. This will be 2 and 1. All right, and then I'm going to make sure I put the negatives here so we don't forget. So we have, this is the cosine, that's negative 1/2. And then we have the tangent, which is just going to be negative root 3 over negative 1. So that's just going to be positive root 3. And remember, it's in the 3rd quadrant, so the tangent's going to be positive. And then we look at the reciprocals. So the reciprocal of root 3, this will be 2 over root 3. So that's going to be negative 2 root 3 over 3, and this will just be negative 2. And then I can write the cotangent, that's going to be root 3 over 3 in rational form. For this last rotation, looking at 2 pi, well, you can know right away that 2 pi is a full rotation, and that would take us right back to the start. So if this is a unit circle with radius 1, this coordinate would be 1, 0. So for this one, you're really going to have to make sure you know the definitions up here we talked about earlier. Sine is the y, cosine is the x, and tangent is the y over x. So when we look at this, sine of 2 pi, the y value is 0. The x value, cosine of 2 pi, would be 1. And the tangent is y over x, which is 0 over 1. and just equals 0. Now, the cosecant, remember, is the reciprocal of sine. So 1 over 0, well, we know we can't do that. That's going to be undefined. Okay, that's not going to be a value that we can find. And then when we have secant, well, the reciprocal of 1 is just 1. And the reciprocal, again, over here for cotangent of 2 pi would be 1 over 0, which again we get, and this was actually 0 over 0. I'll write that more clearly, but that's also going to be 1 undefined. Okay, so anytime we divide by 0, the value is unable to be found. Okay, all right, for the last part right here, we're going to look at the domain and range of sine and cosine, and then consider its period. So looking at the domain of sine. So when we look at the domain and range, we want to make sure we're looking at all the possible values. So all the values for this unit circle, when we look at the x, well, that's going to be between -1 and 1. And we look at the y value, that's going to be -1 and 1. But remember, our x value, or our input, I should say, is actually not x. Our input is the angle, t. So we're looking at t and saying, what do we get for our output? So when we look at sine, we're looking at all the y values. And so the restriction on the range for sine is going to be -1 to 1. And when we look at the restriction for cosine, the range of cosine will also be -1 to 1. So it's important to remember that the domain of these two functions is going to be all real numbers. And what does that mean? That means that we can spin this around as many times positive, or spin it around as many times as we want negative rotations. And there's always going to be an output. There's always going to be a sine value for the sine function, and there's always going to be a cosine value for the cosine function. So remember, on this one, we're not looking at x. Right here is your traditional input, because x is actually all the values of cosine. All right, so when we talk about something that's periodic, we're saying that it's going to continuously happen. It's going to continuously happen in a period. So the definition of a periodic function is that for any real positive number, such as c, if we add c, we'll always get back to the same value. So it's going to cycle through, kind of like a bicycle, if you want to think about that. So if you have a bicycle, it's going to cycle around and you're still going to get the same value, another value that's equal. So we've actually done this already with the last section, looking at coterminal angles. And so coterminal angles is when we add 2 pi. So if you add 2 pi or subtract 2 pi, n number of times is just representing the many times you can multiply or do these revolutions. So anytime you add 2 pi, anytime you subtract 2 pi, you're going to get back to another value. So it's periodic. So you can see right here, you have the pi over 4, and then any other value, pi over 4 plus 2 pi, n will get you back to that location. And then you have something like pi over just pi, or 3 pi, or 5 pi. So as soon as you keep adding 2 pi, you're going to get back there. So anytime you add or subtract 2 pi, you get another coterminal angle, which you guys already know. So that's defining that periodic function. But it is important when we want to solve trigonometric functions. So cosine of 9 pi. Well, we talked about this over here with the pi and 3 pi. So say something's going around here, right? That's 2 pi, 4 pi, 6 pi, 8 pi, 9 pi. So 9 pi would take us back to pi. So I'm going to just write this out, but we know that we can separate 9 pi into 8 pi plus pi. So 8 pi essentially is saying how many you're doing for those revolutions. So cosine of 9 pi would equal cosine of pi. And we know that that's a quadrantal. And so the x value is going to be -1. So when we simplify that, that'll equal -1. Now for -7 pi over 3, well, if this was 6 pi over 3, that'd be a full revolution. So I can rewrite this as -6 pi over 3, and then another minus pi over 3. So this right here is just saying that's going to be a revolution. And then we're going to continue to negative pi over 3. So -7 pi over 3 is going to equal negative pi over 3. And negative pi over 3, that's going to take us into the fourth quadrant. Remember, that's a 60-degree angle. And remember, the sign is going to be negative. And so we know this is going to be -3 over 2. Or sorry, -√3 over 2. I don't know if I said root. So for each of these, I would definitely recommend that you go back to those special triangles, go back and review the unit circle, but in essence, you're really just using coterminal angles to solve these without a calculator. Okay, so the next thing, and this is the last thing we're going to cover for this section, is looking at odd and even. So if you remember, the definition of an even function was if we plugged in x, right, we got a y. And if we plugged in a negative x, we got a positive y. That showed that something was even. So if something was an odd function, we plug in x and get a y, and plug in a negative x and get negative y. So what I wanted to do is just practice a couple of the examples, and we're just looking at 30 degrees. So I'm just going to draw a 30-degree angle here. And we could use the special triangles, or you can go back to the unit circle too. Either one is fine. So here we have a 30-degree, and I'm just going to label this 1, 2, and √3. So when we look at the cosine, right, the cosine is going to be √3 over 2. But if we go and make a cosine of -30, that's going to be in the fourth quadrant. So cosine is the only one that will stay positive. When we look at sine, well, the sine is going to be of 30 is 1/2. But in the fourth quadrant, sine of -30 becomes -1/2. If we look at the tangent of 30, well, that's going to be √3 over 3. And then the tangent of -30 would just be -√3 over 3 because it's in the fourth quadrant. So if you notice, the only one that stays positive would be the even function. So the cosine and its reciprocal are even functions versus everything else. So the sine, the cosecant, the tangent, and its reciprocal cotangent are all odd functions. And this is really from this all students take calculus, that the rules with the coordinates for x and y. So knowing that only the cosine function and its reciprocal secant is even, well, we can evaluate this one pretty easily. It says, find the cosine of t, given that the cosine of -t is 0.3. Well, remember, we know it's even. We know if this is just the negative rotation, then the cosine of t has to also be positive 0.3. Because cosine and its reciprocal secant are even functions. Well, I hope this was helpful today, and I'll see you all in class.